Hello again, everyone. We're starting our second lesson in this trimester, which is 7.5, and as usual, we're starting with brain highways. Pause the video and try to answer the following questions on your own. Okay, let's see what do we have here. We have two functions, f of x and g of x, and he wants me to find their sum. In number one, f of x is negative 2x squared, g of x is 6x. Look closely. If there's any like terms, you have to combine them. If not, you just leave it like this. And this will be the answer. Number two, he wanted to get the difference between the two functions. And he started with g of x. G of x is 6x minus f of x. Remember to use brackets. Or directly, remember to change the signs of the second monomial. 6x minus negative 2x, negative will be positive. So the answer will be 6x plus 2x squared. Number three, a product of the two functions. Multiply f of x, which is negative 2x squared, times g of x, which is 6x. When you multiply two monomials for the numbers, we multiply the coefficients. Negative 2 times 6 is negative 12. For the variables, we add the exponents, yes, x squared times x is x to the power 3. Number 4, it's required to find the quotient of the two functions, to divide them. G of x is 6x over f of x, which is negative 2x squared. Again, for the coefficients, the numbers in front of the variable, you just divide them. 6 divided by negative 2 is negative 3. For the variables, this x is raised to the power 1, and when you subtract 1 minus 2, it's x to the power negative 1. You can directly put it down, x to the power 1. And remember, you can never leave x is equal to 0, because anything over 0 is undefined. So you have to add this one note. X can never be equal to 0. Let's move on. Okay. Again, our lesson is 7.5 inverse functions, and our objective for this lesson is to find the inverses. What are the inverses? Before we move on in our lesson, we need to answer this question. And in order to answer this one, I need you to get your notebook, your square notebook, your pencil, and try to do this little activity with me. You have a table of values here representing a function f of x. Please try to plot this function. Plot those points and graph the function. Okay, I'm changing the color here. Those are the two axes, the y-axis and the x-axis. It's just a sketch of a graph, and let's plot the points now. Negative 2 with 4, negative 1 with 1, 0 with 0, 1 and 1, 2 and 4. Yes, as you expected, it is a parabola. Opens upward. Now, the next step, I want you to start swapping or interchanging the values of x and f of x. Interchange them. Swap x and f of x by making the output of the original, those output of the original function will be the input, and the input will be the output. This is the table you're supposed to have by swapping the domain and range. Now f of x became the input, the output of the original became the input, and the input became the output. Let's name it g of x. And let's try to graph this function. Okay, let's plot the points. 4 with negative 2, 1 with negative 1, 0 and 0, 1 and 1, 4 and 2. this is actually the sketch of the new graph. And this is what we call the inverses of functions. The new graph, this new table, this new graph is representing a new terminology for you, which is called the inverse of function. Let's see if we combine both of them in one graph. The red one is the original function f of x, and the green one, it's the inverse of the original. And this is how we call it. We read it as f inverse of x. This is how we write it. I know that some students mistakenly call it f to the power negative 1. This is totally wrong. We call it, or we read it as f inverse of x. And it's happening when you switch the input and the output values. As you can see here, this is the original function f, and this is the new function g. When we made the range of the original function, when it became the domain of the new one, and the domain became the range, a new relation is produced, which is called the inverse. And one of our objectives to verify whether two given functions, f and g, are inverses or not. Let's see how. If we plug the two functions into each other, we plug g into f and f into g, and they are equal to x, then we can say that they are inverse functions. And this will be our first example. If you're following from the book, you can get your textbook and start following page 380. Given two functions, f of x is x plus 3 and g of x is x minus 3, and he wants you to verify if they are inverses. Let's see how to do it. Again, to verify if two functions are inverses, we're going to plug g into f and f into g. First of all, I'm finding f of g of x. To remind you, I will write f of x here above, and when you plug g of x into f of x, it means I'm replacing this x by g of x, which is x minus 3. This one is pretty easy. X minus 3 plus 3. The 3 will cancel the 3 and you have only x. Let's see if we plug f into g of f of x. When you plug now f into g, again, I will write g here, it's x minus 3. And again, remember, when you find the composition of g with f, this x will be replaced by f of x. f of x is x plus 3. Again, the 3 and the negative 3 will be cancelled, and you're left with x. Now it's your turn. Answer the checkpoint and pause the video for 30 seconds. Okay, this is how we verify if two functions are inverses. I will have to find f of g of x, and then I will find g of f of x. F of x is 3x minus 5. To plug g into f, this x will be replaced by g of x. So it is 3 times 1/3 x plus 5 over 3 minus 5. And why did I use brackets? To remind you that you're going to use distributive property. So it will be 3 times 1/3 x plus 3 times 5 over 3 minus 5. The 3 will be cancelled with the 3, and you're left with x plus 5 minus 5. 5 minus 5 is 0, and you're left with x. Now, you plug in f into g. Again, I will write g, which is 1/3 x plus 5 over 3. And in this case, this x will be replaced by f of x. I will start substituting each x by f of x. So 1/3, and this x is replaced by 3x minus 5 plus 5 over 3. Again, use distributive property. 1/3 times 3x is x. 1/3 times negative 5 is plus 5 over 3 minus 5 over 3. Those will be cancelled and you're left with x. Since both of them are equals to x, then yes, they are inverse functions. That's it for today's tutorial. This is the first part of lesson 7.5. Till we meet again in the second part.